My board's already going to first.
Okie dokie, we are starting our nonlinear systems lesson. As I mentioned already, you were supposed to watch the first video yesterday. I don't put a lot of stock in the fact that you guys did. I'm hopeful you did, but you know, I'm real realistic too.
We're juniors. What do you expect?
So the first thing we're going to cover is what a solution to a system of equations is. So for example, if I have a coordinate plane and I had two lines on this coordinate plane, what would their solution be? Say it again. Where the lines intersect. Okay, so if I have two straight lines, their intersection point would just be one solution because we would only have one intersection point. But that's not always going to be true because we're not always going to have linear equations. So the first thing is when I'm talking about a solution, I'm talking about the point at which they intersect. So that's going to be some xy coordinate pair. If we have more than one intersection point, we are going to have more than one solution point. Okay? So when we're talking about nonlinear systems, I'm talking about some parabolas in there as well. So for example, if I have a parabola in a straight line, I could have two intersection points. If I'm talking about a parabola and another parabola, I could have two intersection points. Okay, so what we're looking at is not necessarily straight lines or a system that includes lines that are not straight. We could also have two parabolas that graph to the same shape. So for example, if I have this green one and I have this red one that overlap completely, what would be the solution to that system? All real numbers or infinite solutions. However you wanted to say it. What if I, instead of having, I don't know, all of them overlapping, I had two equations that never overlapped? It would be no solution. So the number of times that they intersect is the number of solutions we're going to have. They could never intersect, which means we have no solutions, or they could intersect at all points, which is infinite solutions. Okay? Anybody confused by that? If I have a finite number of solutions, so 1 or 2 or 3 or 4 or whatever it is, I expect all of those xy points to be written out. You can't just give me one of them. You have to give me all of them. Everyone okay with that? Okay, so let's go ahead and actually look at some examples. We're going to start with two linear equations because that's what we're used to, and then we're going to build up from there. So the first example is I would like to solve this system of equations. My first equation is negative 3x plus y equals 2. My second equation is y equals x plus 6. Out of curiosity, do you guys remember the different ways that we can solve a system of linear equations like this? Yeah. Substitution, elimination, or by graphing. Graphing obviously takes more work because you have to draw the graph and you got to put it on there. Unless there's a graph already there, in which case you can absolutely use it. Elimination is when we have the same variables in the same places and we can just multiply one or both equations and force a cancellation. And substitution is when one of our equations is already solved for one of our variables or can be easily solved for one of them, and we can substitute what it's equal to into the other equation. Which one do you think we're going to use here?
Y equals x plus 6 and plug it into y.
So we're using substitution here because I'm going to take this x plus 6 and I'm going to substitute it in where the y is in that first equation. So when I do that, I'm left with negative 3x plus x plus 6 equals 2. I want everyone to look at that for a second and make sure you understand where all of that came from and how it got put together. Is everyone okay with that? Now what am I going to do? What do you guys think? So combine like terms and solve for x, because that's the only variable I have present. So I'm going to put the negative 3x and the x together to get negative 2x. Then I'm going to go ahead and subtract the 6 across to the right-hand side. And when I do, I get negative 2x equals negative 4. Because 2 minus 6 is negative 4. And then what am I going to do? Divide by negative 2. And when I do, I get x equals positive 2. Because the negatives cancel, and then 4 divided by 2 is 2. Questions, concerns, or issues with that? Is that my final answer for the solution? What am I missing?
Y.
The y coordinate. So now I need to take this x equals 2, and I need to plug the x into that second equation I had where y is already by itself, and I need to solve for y. So when I do, I get y equals 2 plus 6, which equals 8. So my solution is the point 2, 8. Questions, concerns, or issues? Do we all remember this in some capacity? Perhaps. So of course, we're going to do another one. This time, I'm taking one of these straight lines and I'm replacing it with a quadratic. So we're going to have two equations that are nonlinear when they're together, okay? So this time, I would like to solve x plus y equals 2 as my first equation, and then y equals x squared minus 4 as my second equation. What am I going to do? Am I going to use elimination, substitution, or graphing on this one? Substitution. I can easily see that this bottom equation is solved for y. So I can take the x squared minus 4 that y is equal to, and I'm going to substitute it in where the y is in that first equation. So when I do that, I'm left with x plus x squared minus 4 equals 2. What is this looking like to you guys? A quadratic equation. So what I want to do is I want to combine like terms, get everything over to the left-hand side, and then reorder it so it looks more like the quadratic that it is. So I'm going to go ahead and I'm going to subtract this 2 over. Then I'm left with x plus x squared minus 6 equals 0. I'm going to flip-flop the x squared and the x. And now I have x squared plus x minus 6 equals 0. This is a quadratic that I can solve either by factoring it or by using the quadratic formula. Which one do you think we need to use? Can we factor this one? Can I come up with two numbers that multiply together to get a negative 6 and add to get a positive 1? Yeah, what do we come up with? Opposite? 3 and negative 2, right? Because I wanted them to add to a positive 1, which means the 3 had to be positive because it's the bigger number. Okay, so that does work. 3 times negative 2 is negative 6. 3 minus 2 is 1. So this factors into x plus 3, x minus 2. How do I solve for what my x's actually are when it's in factored form like that? What am I going to do with each of those factors? Set it equal to 0 and solve. So I'm going to have x plus 3 equals 0. x minus 2 equals 0. I'm going to move these around so x is by itself. And then I have the x coordinates of my two solutions. These are just the x coordinates. I now have to find their corresponding y coordinate. So the way we want to do this is technically we could take these and then plug them into either of the original equations. However, as a rule, we want to plug them in to the simplest of the equations. So I want to plug them into the top, because if I plug them into this one, sometimes I get solutions that aren't actually solutions. Okay? So I'm going to take the x equals negative 3, and I'm going to plug negative 3 in for the x here. When I do, I get negative 3 plus y equals 2. I add the 3 across, and I get y equals 5. So negative 3 corresponds to a y value of 5. I'm going to do the same thing with my 2. So I have 2 plus y equals 2. I subtract the 2 over, and I get y equals 0. So x equals 2 corresponds to a y value of 0. And now I have the x and the y coordinates that I can write as points. So my two solutions are negative 3, 5, and 2, 0. Questions, concerns, or issues with that one? How did we feel about that?
Not very confident.
Well, it's the first one, so I expect that.
It's a lot of work.
Always a lot of work. It's math class. Come on. Of course, we're going to do another one as a practice. Is everybody ready? Just so you know how I'm breaking this up, today we're focusing on substitution. Tomorrow, then, we can do elimination. I don't want to overwhelm you, okay? So the next set I would like for you to solve is x minus y equals negative 1. And then y equals x squared plus 1. If you feel comfortable, of course, you're more than welcome to move through this on your own. If you don't feel comfortable, hang out with me and we'll do this together, okay? So for those of you who are moving with me, what are we going to do first? So Ebony, what are we going to do first?
Substitute the y with x squared plus 1.
And for the y in my first equation, good. So when I do, I get x minus x squared plus 1 equals negative 1. Before I do anything else, I need to distribute that negative. That was my subtraction. When I do, I get x minus x squared minus 1 equals negative 1. Now what do I do, Madison? What is it starting to look like to you? Okay, so I need to get everything to one side, right? And then I can reorder as a quadratic. So she said to add this 1 over, which is awesome. So when I do, I get x minus x squared plus 0 equals 0. Of course, I want to reorder this so it looks more like a quadratic. So I have negative x squared plus x plus 0 equals 0. As I'm looking at this, it's probably not going to be the easiest for me to factor this. So what alternative way can I use to find the solutions to a quadratic? Quadratic formula. Let's give her a try. So I first need to know what a, b, and c are. So a is negative 1, b is 1, and c is 0. So I plug it all in. When I do, I get negative 1 plus or minus the square root of 1 squared minus 4 times negative 1 times 0, all over 2 times a negative 1. I want to simplify this. The first thing I notice is that negative 4 times negative 1 times 0 is just 0, so that's going to disappear. I'm going to be left with negative 1 plus or minus the square root of 1 over negative 2. What's the square root of 1?
One.
1. So that just becomes -1 plus or minus 1 over -2, and I can split it into 2 problems. First one is -1 plus 1 over -2, and then -1 minus 1 over -2. What's -1 plus 1?
0.
What's 0 divided by -2?
0.
0. So -1 plus 1 over -2 is 0. Then I do -1 minus 1 is -2. Divided by -2 is +1. So my two x values are 0 and 1. Everyone okay with that? Okay. So now what do we want to do with that x equals 0 and x equals 1? Do I want to just leave them? Is that my final answer? Do I need to plug them back in? What do I need to do? Plug them in and find my y so I can write them as an xy coordinate pair. So I'm going to go ahead and plug them into the top equation because I like to go for the simplest one. So I plug in 0 for x and I get 0 minus y equals -1. That's just -y equals -1. I can divide each side by -1 and I get y equals 1. So my first solution point is 0, 1. I repeat this process with x equals 1. So I get 1 minus y equals -1. I subtract the 1 over. I get -y equals -2. Divide by -1, and I get y equals 2, which means that my solution is 1, 2. I'll give everyone a minute to catch back up. How is everyone feeling about this so far? Emily?
So you have 2 coordinates, right? Are both those your answer?
Both of these are my answer, yes. Because one's a quadratic and one's a straight line, so I'm assuming it's intersecting in the 2 spots because it gave me 2 answers. Questions, concerns, or issues for this? Are we ready for another example? Yes, okay. So the next example I have is another set of nonlinear equations. I know you're all so excited. So for this one, I would like to solve x squared plus y squared equals 100. And then y minus x equals 2. As I'm looking at this, substitution is definitely the way that I'm going to go. So I need to get that bottom equation solved for one variable. I choose the bottom one because it's just x and y. There's no square there. So it's going to be the easiest to isolate. Am I going to solve for y or x on that bottom equation, do you think? Technically, there's no wrong answer, but one of them is just going to be an easier solve. Which one's going to be easiest to solve for, y or x? Y. How did you know that? Okay, well, technically we could deal with y as well, but I like the way you're thinking. How about the fact that y is positive, but x is negative here? So if I were solving for x, I would have to move, and then I'd have to divide. If I'm solving for y, all I have to do is move the x. So always go for the easiest solve. So here, I'm going to have y equals x plus 2, or you could have 2 plus x. I just like to put the variable first. So now I'm going to substitute x plus 2 into my equation for the y. But what do I notice about the y? It's squared. So when I plug that x plus 2 in, it's going to be x plus 2 squared. Okay? So then this is going to become x squared plus x plus 2 squared equals 100. Before I do anything else, I'm going to have to deal with that x plus 2 squared. What does that turn into? X plus 2 times x plus 2, which means I'm going to FOIL it out. So then this becomes x squared plus x plus 2 times x plus 2 is 100. I'm going to FOIL this x plus 2 times x plus 2 out. I'm going to color code it for anybody who needs the practice. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. And then 2 times 2 is 4. I still have the rest of my problem in here, so I still have the x squared at the front, and I still have the equals 100. Is everyone okay with how I FOILed that? Hannah, what am I going to do next? Combine like terms. So what can I clearly put together here? Okay, so I can put those two together. It becomes 2x squared. I can put the two 2x's together, and that becomes 4x. And then plus 4 equals 100. I know this is a quadratic, so I definitely want to try and get everything on one side of the equal sign. So what am I going to do with that 100? Subtract it over. When I do, I get 2x squared plus 4x minus 96 equals 0. Now I would like to solve this, but I have to do something first, or I have to identify something first. What do I notice about all three of these terms? Say that again. Who said it? They're even, which means they have a common factor of 2, because they're all divisible by 2. So I need to divide all of these terms by 2, which will leave this in a form that will allow me to either quadratic formula it or factor it. So 2x squared divided by 2 is x squared. 4x divided by 2 is 2x. Negative 96 divided by 2 is negative 48. And 0 divided by 2 is still just 0. So now I have x squared plus 2x minus 48 equals 0. I would like for us to factor this one. I don't want to use the quadratic formula here. So I would like for you to factor this, which means I'm looking for two numbers that multiply together to give me negative 48 and add to give me a positive 2. Everybody think about it. Camden, what's that face for?
Huh?
You spacing or are you thinking?
No, I'm just thinking, I can't, anything that's like above like 6 times 6, I can't do it. Unless it's like a square, you know?
Okay, so maybe we just start listing factors and we'll go from there. So what multiplies together to get negative 48, Camden?
See, that's past 36.
Well, we have a calculator, which helps us. So let's just start at 2. What's 48 divided by 2? Or negative 48 divided by 2? Okay, so I have 2, and I have negative 24. Does 2 plus negative 24 equal a positive 2?
No.
No. What about negative 2 and positive 24? Does that give me a positive 2 when I add it together?
No.
No. So I move on. What's negative 48 divided by 3? You have calculators in front of you. You can definitely figure that out. Negative 16, good. 3 minus 16 is a negative 13. That's definitely not positive 2. So then what if I flip them? And what if I do negative 3 and positive 16?
Still no.
Positive 13 doesn't work. But I'm getting closer. So then what's negative 48 divided by 4? Because that's the next number. What is it? Okay, so I have 4 and I have negative 12. 4 minus 12 is negative 8. Nope, still not what I'm looking for. So let's flip the signs and see if that works. What's negative 4 plus 12? Positive 8. Nope, still not what I'm looking for because I'm looking for 2, but I'm getting closer. What's negative 48 divided by 5?
It's not a whole number.
It's not a whole number, so I don't include it in here. So then I go to the next one. What's negative 48 divided by 6?
8.
Okay, so I have 6 and I have negative 8. 6 minus 8 is negative 2. Is that what I was looking for?
No, but it's close.
It's the right integer with the wrong sign. So I just need to flip the signs on the two numbers that I found. So now I have negative 6 and positive 8, which gives me a positive 2, which works. So this factors into x minus 6, x plus 8. Which means I set each of those equal to 0, and it allows me to solve for what x is equal to. When I do that, I get x is equal to 6 and x is equal to negative 8. Questions on that? We're okay with that. What am I then going to do with that 6 and negative 8? Plug them back in to which of my two equations, Camden? The easier one, so this one. I'm going to plug them back into that. So I'm going to start with the x equals 6. I'm going to plug 6 in, and I get y equals 6 plus 2, which is 8, which means my first solution point is 6, 8. I'm going to do the same thing then with negative 8. I get negative 8 plus 2, and that equals what?
Negative 6.
So then my next point is negative 8, negative 6, and both of those are my solutions. How do we feel about that one? Okay, terrible. Does it kind of make sense? I know it's a long process, but does the process make sense? For the most part. Yes, okay. Okay, we have a couple more. I'm actually going to skip this one because it's just like the one we just did. And we're going to move to this one. I know you're all so excited. So excited. Okay. So now I would like to solve x squared plus y squared equals 25. And y squared equals x plus 5. Quick question, am I going to use substitution or elimination here?
Substitution.
Substitution. How did you know that, Ebony?
This y squared equals x plus 5. I'm plugging into y squared first.
Okay, so she recognized that my second equation already has the y or the y squared isolated, which is awesome. So I'm going to take what y squared is equal to, which is x plus 5, and I'm going to replace the entire y squared with it. So it's not like the previous problem where we had y equals something and we had to plug it into a y squared. We're replacing this entire y squared with the x plus 5 because I have y squared equals that. Okay? So when I do, I get x squared plus x plus 5 equals 25. And I know what to do from here. So from here, on your own, using factoring, I would like for you to solve this system. This one's a try it on your own from here problem. I can't tell if some of you are staring because you're done or because you're lost. I lost my pen. Ariana, start me off.
I don't know.
You have no ideas. What does this look like to you? It looks like a quadratic, but I have a number on the right-hand side of the equal sign. So what am I going to do with that? Okay. Which leaves me with x squared plus x minus 20 equals 0, because 5 minus 25 is negative 20. Now I wanted to factor this, Ariana, so what am I looking for? Two numbers that multiply to what and add to what?
Oh,
So multiply to negative 20 and add to what? Is that a 0?
oh, 1.
That's a 1. Okay. So now we're just going to start going down the list. Ariana, what's negative 20 divided by 2? Okay, so I have 2 and negative 10. What does that add up to? Is that what I'm looking for? Okay, so what if I flipped the signs? What would my answer be? 8, still not what I'm looking for. Oh, goodness. So then I do negative 20 divided by 3. What's negative 20 divided by 3? Does it divide out evenly?
No.
No. You can put it in your calculator. You'll see it's a fraction, or a decimal, I mean. Not going to work. So then I move to negative 20 divided by 4. What is it?
5.
So I have 4 and negative 5. That adds up to a negative 1. Is that what I'm looking for?
So we're close.
But if I flip the signs, that negative 1 is going to turn into a positive 1, which is what I'm looking for. So that negative 4 and 5 adds up to a positive 1, which is what I wanted. Which means this factors into x minus 4 and x plus 5, which then I can separate and set equal to 0 to get x equals 4 and x equals negative 5. What do I do next? Is that my final answer? No, I'm still missing my y coordinates. So what do I need to do with those x's? What do I do with those x's, everyone? Plug them back in. I want the simplest equation. Which one of those is the easiest to look at and work with, do you think? Well, they both have a square in them, so I'm not going easy that way, which means I'm probably looking at the one that's already solved for the variable I want to solve for. So am I going to use the top one or the bottom one? The bottom, because it's already solved for y squared, but you could also use the top one if you chose because they're both squares. Okay, so neither one of them is more simple than the other. So I'm going to take x equals 4. I'm going to plug 4 in for x, and I'm going to solve for y. So when I plug 4 in, I get y squared equals 4 plus 5. I put the 4 and the 5 together, and that gives me a 9. Then how do I get y by itself if y squared equals 9? Square root it. When I square root it, what's the square root of 9?
3.
And
Negative 3.
positive and negative 3. So both of those are going to be y values on points with an x value of 4. So this correlates to two answers. It correlates to 4, 3 and 4, negative 3. So one x value gave me 2 solutions. That's okay. But I'm not done because I haven't tested negative 5 yet. I have to plug that back in too. So I'm going to take x equals negative 5, and I'm going to do the same thing. So I have y squared equals negative 5 plus 5. What's negative 5 plus 5?
0.
0. What's the square root of 0? So this one only gave me one solution, which is also okay, because you can't have a positive 0 or a negative 0, it's just 0. So then this gave me the solution, negative 5, 0. So all three of my solutions are my answer here. All three have to be present. Is everyone okay with that? If this had given me 2 solutions as well, I would have had 4 solutions in total for this answer. That is 100% possible. Questions, concerns, or issues so far? Okay, we have 2 more examples left. I'm going to try and get through both of them. Okay? So this first one asks us to solve this system. The first is y equals x squared minus 4x minus 10. And the second one is y equals negative x squared minus 2x plus 14. As I'm looking at this, am I going to use substitution or elimination?
Elimination.
Substitute. They're both solved for the same variable. They're both solved for y. So what I'm going to do is I'm going to take this and I'm going to put it where the y is in that top equation, which means I'm technically taking these 2 equations and setting them equal to each other. So I'm going to have negative x squared minus 2x plus 14 equals x squared minus 4x minus 10. And just like before, I want to solve this by getting everything to one side of the equal sign, because this is probably going to be a quadratic. And then I can use either factoring or the quadratic formula to solve. So I'm actually going to go ahead and move everything to the right-hand side because I think that might be easiest. So I'm going to start by adding this x squared over. Then I'm going to add this 2x over. And then I'm going to subtract this 14. So when I do that, x squared plus x squared equals 2x squared. Negative 4x plus 2x is a negative 2x. And negative 10 minus 14 is a negative 24. And that is equal to 0 because I moved everything from the left over to the right. I'm going to look to see if there's a common factor in this before I try to factor it. So is there anything that can come out of all 3 of these terms? 2. So we divided 2 out of everything. When I do, I'm left with 0 equals x squared minus x minus 12. And now I can go ahead and factor it. So if we're building our table, I'm looking for 2 numbers that multiply together to get a negative 12 and add to get a negative 1. I want you guys to work through it on your paper, doing the chart like we have been in the last couple examples, till you find the one that works. When you have the one that works, check with somebody sitting next to you, and then we will do it together as a class. Ariana, I'm going to call on you. Negative 4 and 3. Good. I know that works because negative 4 times 3 is a negative 12, and negative 4 plus 3 is a negative 1, so that checks out. So then I take each of those and I set it equal to 0, and I get x equals 4 and x equals negative 3. Carly, what am I going to do with those numbers? Plug them in. Does it matter which equation I use? No, because they both have the same y, right? So it's not really going to matter. They both have the same x's. So I'm just going to pick one to plug it in. I'm going to use the top one because my x squared there is positive, which makes it easier to work with. So I'm going to take my x equals 4, and I'm going to plug it in. When I do, I get 4 squared minus 4 times 4 minus 10. I simplify that into 16 minus 16 minus 10. 16s cancel, leaving me just with a negative 10. So 4, negative 10 is going to be my first solution point. I'm going to do the same thing then with my x equals negative 3. So when I plug it in, I get negative 3 squared minus 4 times a negative 3 minus 10. Negative 3 squared is 9. Negative 4 and negative 3 is positive 12. And then minus 10. 9 plus 12 is 21. Minus 10 leaves me with 11. So 4, negative 10, and negative 3, 11 are my two solutions. Questions, concerns, or issues? Does that make sense to everyone how we did it? We are almost out of time, so we're just going to do the setup for the next problem, and you can finish it out on your own. It is in the notes, okay? And this next one is our last problem that we were going to do today anyway. So the next problem asks us to solve xy equals 6 and 2x minus y equals 1.
How?
Give it a second. So this one is definitely different than what we have looked at before because it has multiplication between the x and the y in the first equation instead of addition or subtraction. It's still okay. It's still an equation. It's just not a straight line, which is fine. So we're still going to use substitution here, which means I'm going to need to solve this bottom equation for one of my variables. Which one do you think I should solve for, x or y? Y. If I solved for x, I would have fractions because there's a 2 in front of my x. So I definitely don't want to do that. So since I'm solving for y, I'm going to subtract the 2x over, which leaves me with negative y equals negative 2x plus 1. But I don't want negative y, I want positive y. So what am I going to do? Divide everything by negative 1. When I do, I get y equals 2x minus 1. And this is what I'm going to substitute in for the y in that multiplication equation. So then when I substitute that in, it becomes x times 2x minus 1 equals 6. I go ahead and I multiply that out. I get 2x squared minus x equals 6. I know this is starting to look like a quadratic to me, so I need to move the 6 over to the left. So I need to subtract it over. And when I do, I get 2x squared minus x minus 6 equals 0. There is no common factor, so factoring is probably not going to be very easy since I have a number in front of my x squared. So I'm actually going to use the quadratic formula here. And we would use that to finish solving it out. When we got an answer, we would plug it back into this 2x minus 1 equation, and it would give us the y coordinate that we were looking for. Okay, so you're more than welcome to finish this one on your own. It's a really good quadratic formula practice, but I also want to give you a couple minutes maybe to look at the homework before you are dismissed from class. So anybody online, if you have questions over the homework at any point, please feel free to email me. And then tomorrow we're going to do elimination. Okay, so this homework is not due tomorrow. It will be due on Friday. Okay, sound good? Awesome. Yeah, I do not. I'm sorry.